Spectrometer reading confirms mil-spec 901.
Okay, cross-reference with the heat number and log it.
Copy that. Moving the next ingot now.
The ultrasonic readings look good across the length.
And the dimensional measurements are all within tolerance on the chart.
Very well. Go ahead and apply the stamp.
Inside the normalizing furnace, the gun barrel reaches a uniform 1650 degrees. The roller hearth
Cooling rate holding steady at 50 degrees per hour.
confirmed. The transition looks good. This 45-foot horizontal lathe is specifically designed for gun barrel work. The crane lowers the cooled blank, ensuring perfect concentricity.
The graphical representation clearly shows the variation along the length.
Hold position, we have alignment issue on the far right.
Copy that. Adjusting trajectory now.
Senses. Ensuring centerline alignment down to 0.010 of an inch requires constant temperature control and laser inter.
The broach is clear. Check the final twist rate measurements.
Verification complete. The lands and grooves are perfect.
Precision indexing ensures the crown is perfectly perpendicular to the bore center line.
Chamber dimensions are fully compliant.
Muzzle crown perpendicularity checks out. We are cleared for certification.
We have clear indications here.
Documented. The borescope shows the interior is sound.
There's a clear indication at the 12-inch mark.
Let's check the C-scan. It looks like a lamination, roughly a 1/4 inch.
Looks good. We have equilibrium. Mark it. Marking the center line now. Weight confirmed at 20.001 tons.
All stations confirm go for fire in 5.
Solid copy. Range is hot. Easy now. Lower it slowly.
Watch the alignment on the breech. Secure the bolts.
Exterior surfaces look good. No signs of structural damage or gas leakage at the breech.
Confirmed. Data logged for successful proof.
The scan is complete. Erosion is within tolerance.
Confirmed. The barrel meets all acceptance standards.
The scan is complete. Identical signature. Excellent.
Commander, the post-proof data confirms 0 structural changes.
The heat treatment certification for Lot 4B is fully compliant.
And the dimensional measurements align with the specifications. This barrel is accepted for service.
Lower gently onto the pads, centered perfectly.
Straps are secured. All clear for transport. manifest for the main armament. All right, driver, cleared to proceed to the heavy lift zone. They're waiting for you at the dry dock.
All right, take the tension slowly. We are clear below. Roger that, ground crew. Lifting now.
Watch the clearance on that hoist. All right, slowly lower it down now.
Advancing slowly. Watch the clearance on the lugs.
Clear on this side, keep coming back.
Specified torque reached on bolt 4.
Verified. Mark it complete and proceed to the next fastener.
We are bringing the barrels up to 45 degrees.
Synchronization is holding steady at maximum elevation.
Cycle complete. No external leaks detected.
Data recorded. System performance verified.
All right, cycle the mechanism open. Opening the breech now, sir. Good, now lock it back down. Hoist 1 engaging. Clear the lower barbette. Acknowledged.
We have green on the interlocks.
Check the schematic for the elevation signals. Junction box J5.
Reading confirmed. Circuit continuity is good.
Alignment looks good.
Hydraulics are primed.
Fire control systems are green. Ready for hoist.
The tubular is closed.
The installation of the roller path is a critical milestone. These massive structures must support thousands.
Area clear. Proceed with the hoist.
Roger that. Taking the tension now. Steady as she goes. Bring her down 20 centimeters. Steady as she goes. Roger that. 20 centimeters down.
Take it down easy, just a hair to port. Looks clear. Hold it, hold it. Stop. We're seated. Alignment on the forward mount looks good, but check the torque on position 7. Already handled, Supervisor. We are within tolerance. Bearing now approaching 300. Pressure is stable.
Confirmed. The rotation is perfectly smooth.
Projectile up. Stand clear. Clear. Rammer forward. Powder secured. Close the breech.
Target bearing 045, range 2000.
Data entered. Awaiting solution.
Fire control, stand by. Turret 1 reports ready, sir.
All stations, commence firing sequence.
Analyze the dispersion radius.
Confirmed. The pattern is exceptionally tight, right on target. All right, running the scope in now. Check the heat stress at the throat. Clear on the exterior. Screen shows minimal crazing.
As predicted, the throat erosion is significant here.
Based on these wear rates, we're looking at maybe 200 rounds remaining.
The precision-manufactured barrels fulfilled their intended purpose, projecting American naval power throughout the Pacific theater.
Target bearing 150. Solution set. Commence firing. Splash. Adjusting 2 degrees right.
The great battleships, once symbols of naval power, were now meticulously prepared for an uncertain.
Fire to battleship. Target acquired. Continue mission as planned.
A blend of 1940s mechanical might and 1980s digital precision, preparing the fleet for a new era of conflict.
Clear the deck, move out! All clear up top, Captain. Final salvo complete.
The manufacturing process alone took months. From the steel mills to the final installation, it was a massive undertaking.
The precision required for these large naval guns represented the pinnacle of wartime industrial achievement and manufacturing capability.
This lathe here is a testament to the sheer scale of the WW2 mobilization effort. The workers here...
This reveals the incredible coordination between the foundry and the machining teams.
And the proof firing data correlates perfectly.
The chemical analysis confirms the precise alloy composition.
And the mechanical testing shows why these barrels lasted 50 years.
While the technology has evolved from manual labor to advanced CNC systems, the fundamental principles of metallurgy and precision remain the same.
It was hard work, long hours, but we knew the quality of these barrels meant everything.
We were proud of what we did for the war effort.
The scale of this mobilization was unprecedented. It wasn't just about building guns, it was a total economic transformation.
The lessons learned from these battleship operations, particularly in precision manufacturing, laid the foundation.
The global technological race was fierce. While all powers manufactured these behemoths, the sheer volume of America...
The correlation is clear, but this success relied entirely on the quality of the precision manufacturing back home.
From the roaring shipyards of the 1940s to the museum berths of today, battleships hold a unique place in the American memory.
When we talk about manufacturing tolerances, we mean the acceptable margin of error. On these guns, that margin was incredibly small.
We had to make sure the hydraulics were pressurized before we could traverse the turret.
And the powder charges came up from below right here. It was hot work.
Through advanced 3D laser scanning and photogrammetry, we create precise digital models, ensuring these are...
The preserved artifacts allow us to analyze the exact stresses on the barrel.
This data supports the hypothesis regarding the increased muzzle velocity.
Proceeds. By utilizing these advanced material sciences, we project a 50% extension on hull integrity for the next century.
The journey from the mill to the museum reflects the lasting value of quality engineering and commitment to victory.
By preserving these artifacts, we ensure the stories of the past continue to inspire future generations about